Welcome to revision worksheet 9. So this revision worksheet focused on questions on the line and featured two questions. The first was from the DEB mock from 2017. It was paper 2, section A, question 1. And the second question was also a DEB mock. It was the 2015. It was paper 2, section A, question 1 also. So we're going to work through these, and the line generally features at least one question on paper 2 every year, or has done since the introduction of Project Math. So it is an important concept and a question for you to have. The more questions that you see, the more styles of questions you see, the more things that can be asked, the better. So mock questions, although generally are more difficult, they're very good to see how the basic formulas and the basic ideas are used in maybe a more complicated or tougher way. So question 1, it says 2 points P, which is -4, -7 and Q, 1, 3 lie on opposite sides of this particular line. Calculate the ratio of shortest distance from P and Q to the line L. So when we see shortest distance, we need to think of our perpendicular distance formula. So that's really important. So your perpendicular distance formula is going to be on page 19. Of your log tables. So at the very top of page 19, you'll find your shortest distance formula, and that's what we're going to use. So if we take a look at this diagram here, now just bear with me because I haven't got a ruler on this, but we're basically trying to calculate this distance here, this perpendicular distance, and this perpendicular distance here. Okay. So the first thing we're going to do is P to L. Okay, so we have -4, -7, which is x1, y1. And we have 2x plus y plus 7 equals 0, which A equals 2, B equals 1, and C equals 7. And the formula we're looking at, the distance is equal to ax1 plus by1 plus c all over the square root of a squared plus b squared. So subbing into our formula here, we get 2 times -4 plus 1 times -7 plus 7, square root of 2 squared plus 1 squared. And working that out, we get 8 over root 5. If you're putting that into your calculator, it will probably simplify it down. Say root 5 over 5. Both are the same. So then the second one we want is Q to L. Same formula, but this time we have Q, which is 1, 3, and that's our x1, y1. Our line is still the same, 2x plus y plus 7 equals 0. Again, A is 2, B is 1, and C is 7. Our distance then here is 2 times 1 plus 1 times 3 plus 7 all over the square of 2 squared plus 1 squared. And that will work out for you as 12 over root 5, but again, if you're using your calculator, it doesn't like having our side on the bottom, so it might change it to 12 root 5 over 5. So they want the ratio of the shortest distance from P to Q to the line L. So basically we want 8 over root 5 is to 12 over root 5, which simplifies down. 8 is to 12, divide both sides by 4, or 2 is to 3. So that's our final ratio. This is a really good example where leaving it in third form makes the question and I suppose your answer a lot easier than if you were to try use decimals or rounding it in some way. If you use decimals, you might get this really nice cancellation that happens here at the end. So oftentimes it's in your interest to work with fractions and thirds rather than changing things into decimals. So then it said calculate the ratio of the distances from P to Q along the line L. Calculate the ratio of the distance from P to Q to the line L along the line PQ. So this time we have a diagonal line that's going from Q to P. So we want to find the distance from Q to the line and from P to that line. So first thing we need to do is we need to find the equation of PQ because that's what we're using. We're splitting PQ into two pieces and that's what we're looking at. The PQ is going to be split from Q to the line L and from P to the line L. So to get the equation we need the slope. So the slope of PQ we need to work with our 2 points P, which is minus 4, 7, and Q, which is 1, 3. This is our x1, y1, x2, y2. Our slope formula, y2 is page 18 minus y1, or x2 minus x1. So we get 3 plus 7 minus minus, and 1 plus 4. And that simplifies to 10 over 5, which is 2. So then to actually get the equation, we have y minus y1 is equal to m bracket x minus x1. So again, this is coming from page 18. So we have y plus 7, I'm going to use our y1 from above, 2 times x plus 4. We get y plus 7 is equal to 2x plus 8. So y is equal to 2x plus 1. So the next thing we want to find out is the point of intersection. So effectively what we have, and I'm going to just sketch here just so we can see. You do have a picture and it's just unfortunate I haven't brought the picture here. But we basically have a line that's going like this. We have a point here and we have a point here. So what we're trying to do is figure out, well, look, if we have this line here, so this is P and this is Q, what is the distance from Q to this point here and from P to this point here? And that purple point here is the point of intersection. So really, the only reason we wanted to find the equation is to help us get the point of intersection. So we now have, this is PQ. Now I'm going to rearrange this slightly, so 2x minus y plus 1 equals 0, because we're going to have two equations. We have the first one which we were given, plus y plus 7 equals 0, and that's this line here, line L. The second one is then the one we just worked out, minus y plus 1 equals 0. So to get the point of intersection we're going to do simultaneous equation. Notice here how those y's cancel straight off. So we get 4x plus 8 equals 0. So we get 4x equals minus 8, x is equal to minus 2. And then we want to sub that back in. So we go to 1 and we get 2 times minus 2 plus y plus 7 equals 0. So we get minus 4 plus y plus 7 equals 0. So y plus 3 equals 0. So y is equal to minus 3. So that point is minus 2 minus 3. So now that we have that midpoint, we're going to calculate the distance from Q, which is 1, 3, to the midpoint, which is minus 2, minus 3. And we're going to do that just using our distance formula. So let's label them first. x1, y1, x2, y2, I'll do a little arrow here so we know that it's distance. Okay, so it's x2 minus x1 squared plus y2 minus y1 squared. So for this, minus 2 minus 1 squared plus minus 3 squared, and what we end up with here is 3 root 5. So that's the point Q. So then we can do the point P, same idea, minus 4 minus 7, which goes to the point minus 2 minus 3. I'm going to work that out. So again, we'll label x1, y1, x2, y2, square root of x2 minus x1 squared plus y2 minus y1 squared, and when you work that out you get 2 root 5. So the ratio of the distance P to Q along the lines PQ, so we get 2 root 5, so that's P is to 3 root 5, and simplifying that down you get 2 is to 3. So then Tim, what conclusion can you draw from your answers in part A and part B above? Explain your answer with reference to a geometric theorem on your course. So A, we found that the ratio was 2 is to 3 in its simplest form, and in B we found that it was 2 is to 3 in its simplest form. So let's actually take a look at the diagram here. So first of all we worked out this, and that was the perpendicular distance, which meant that this was a right angle here. We then looked at P is to Q like this, and we had a point here. So we know that the ratio of those blue lines are the same as the ratio of the red lines. Okay, so what we can say about these two triangles is that these two triangles are similar triangles. So how we could explain that is, so the two sides of the triangles are in the same ratio. So this blue line is this line here, the blue line from Q, and the blue line from P, it's 2 is to 3. Similarly with the red line, it's 2 is to 3. Given that they are the same ratio, we can conclude that the triangles are similar. So let's write something down for this. So given that two sides of the triangles are in the same ratio, the triangles are similar triangles. Okay, and this is the converse of theorem 13, which has got to do with similar triangles. So theorem 13 works in two ways. The first is that if you have similar triangles, that the sides are in a given ratio. The other way works if they're in a given ratio, they are similar triangles. So that's the word converse. It works in the opposite way. So nothing terribly difficult there, but it was hard to kind of see this without drawing it out, and especially that link to something in the geometry course as well, but it's really good to see and to understand all those links. So let's take a look at question 2 then. So it tells us OPQR is a parallelogram where O is origin 0, 0, and the coordinates of P are K0 and the coordinates of Q are 4, 2. They also tell us that OR lies on the line y is equal to 2x. Now, it's important, there's a few little bits of information here that you have to look beyond what we're told. So the first is that the point OR lies on the line y is equal to 2x. Note that that has no constant, so it must cross the x-axis or the y-axis or both axes at 0, 0. So basically, because y is equal to 2x, when x is 0, y is also 0. So it passes through the point 0, 0, and that's really important, and I'll explain why in a second. So this line passes through 0, 0. Okay, so OPQR is a parallelogram, so we're basically trying to figure out the value of k. So the only other thing that we know is we don't really have enough information. If we had 3 points, we could work with distances and things like that, but we don't. However, with a parallelogram, like the name suggests, that the sides are parallel. So based on a parallelogram, if you just randomly draw the points as they're given, so say this is O, P, or Q. Now that's a very simplistic one. Sorry, O, P, and then Q should be up here because they're named in order. Q, or. So by that logic, O, or must be parallel to P, Q. And that's what we're going to say, because O, or, the slope of O, or, is based on that line. So the slope of O, or is equal to 2. And we're taking that straight from here. So M is equal to 2. That's coming straight from here. And we know that that's parallel to the slope of PQ. Now for PQ we have 2 points, K0, which is for P, and Q, which is for 2. So this is x1, y1, x2, y2, and the slope formula, which is on page 18, is y2 minus y1 over x2 minus x1. So that's 2 minus 0, 4 minus k. So that's 2 over 4 minus k. So we know that those two slopes should be equal. So therefore, 2 over 4 minus k must equal 2, since O, or is parallel to PQ. And rearranging this, end up with 2 is equal to 8 minus 2k. 2k equals 6, k equals 3. So using that idea of parallel lines. Now, it was probably a little bit difficult given the way that they presented that or being on that line and the idea of the slope of O, or. But having covered the idea of no constant means it passes through the origin, you need to be aware, you need to be on the lookout for things like this that will help you. So the next part asks us for the coordinates of or. So we now know basically 3 of the points. We have the origin here, which is 0, 0. We have the point P here, which instead of K0 we can now say is 3, 0. Q is 4, 2, and or is some x, y. Now we can have the idea of a translation, and we can see it here. So if I go from P, 3, 0 to Q, what is my rule that I do that? So for that, I'm adding 1 to the x part and I'm adding 2 to the y part. By that same logic, I can go from the origin, 0, 0, use the same translation and end up at 1, 2, which is or. Now, you can use the idea of distance and slope, but it becomes too complicated. So we're just using that idea of a translation. So translating or moving from P to Q is the same as translating or moving from O to or. It is using the distance, but just in a simplistic way. So it then says, hence find the area of the parallelogram OPQR. Now, the base by the perpendicular height is how we would work out the area of a parallelogram using traditional methods. However, remember that sometimes there may be an easier way given we're not working in the traditional just lengths, we're working in coordinates. So if you take a look, one of our points is 0, 0. And that's useful for us because if I have my parallelogram like this, I have a triangle. and I have a triangle where one of my points is 0, 0. So if I work out the area of the triangle OPR, I can then multiply it by 2, because this triangle over this side will be the same. So I can use my formula here, which is a half. Now let's get all these set up. So my origin is 0, 0, I don't need that. P is 3, 0, and R is 1, 2. So the half of x1, y2, x2, y1. So that's a half. x1, y1, x2, y2. Half of 3 times 2 minus 1 times 0, half 6, which is 3, but then multiplying it by 2 gives me 6 units squared. Okay, so that's my area here of OPR. Now it worked the same if you went OPQ, but you would need to include that O unless you wanted to do a translation, then becomes more difficult. The other option would be to use the idea of the perpendicular height. So from a point to a line, we do have the equation of the line, so we could do from P, the distance from P to R, so we could use that formula, but it's just a little bit more complicated. The easiest way is to look and use the triangle formula and double. So part B, the line OS has a positive slope and intersects the line PQ at S such that the angle OSP, so the angle at S, is equal to 45 degrees. Find the coordinates of S. So first thing we need to do is we need to look and see, well, how are we going to figure out the angle between two lines? We can do that using the formula which is in your log tables on page 19. And it's the tan of theta is equal to plus or minus the slope 1 minus slope 2 all over 1 plus slope 1 by slope 2. So it's at the top of page 19. It's the angle between two lines of slope M1 and M2. So that's the formula we're going to work with. So the two lines we're talking about here is we have the line OS and the line PQ. Now, given that we don't know what S is and the question is asking us to find the coordinates of S, we can say M1 as the slope of OS, and we're just going to let that equal M. We don't know what it is, we'll just let the letter M stand for that. So M2 is equal to the slope of PQ. Now, back in part A and part I of that, when we were finding the value of K, we actually worked with the slope of PQ, and we said the slope of PQ was the same as the slope of OR, which was equal to 2. So you don't need to go work that out again. We have that information earlier on in the question. So now, working with this formula here, we have the tan of theta is equal to plus or minus M1, which we're going to have M minus 2, 1 plus M by 2. Now, we've been told that the angle is 45 degrees. So the tan of 45 degrees equals plus or minus M minus 2, 1 plus 2M. And in the log tables or using your calculator, whichever way you want to do it, we can work out that the tan of 45 degrees is 1. Plus or minus M minus 2, 1 plus 2M. Now, there's a plus and minus here, so we have two options. So we have where we could take the positive. If we take the positive option, what we end up with is 1 plus 2m is equal to m minus 2. Working through that, we get m is equal to minus 3. Now, that is not correct because we have been told that it has a positive slope. So the working with that positive sign in that formula is not going to work. So if we instead then work with the negative sign, we get 1 plus 2m is equal to minus m minus 2. Notice I'm using the bracket here, and that's to make sure that all the signs are changed correctly. If you don't use the bracket, there is a chance you might just change the sign on the m and not the minus 2. You leave that as a minus 2 instead of changing it to a plus 2. And that obviously will give us the wrong answer. So we have 2 minus 1, which is 1. So m is equal to a third, which is our positive answer, which is our positive slope. So that is, we've worked out our slope. And it's our slope of OS, m. Now, that wasn't what they wanted. They wanted us to find the coordinates of S. Now, although we know the slope, the coordinate of S itself, we know, well, we'll have to say S is equal to x, y. So we don't know the x or the y coordinate. Because of that, we can't just straight away use our slope, because that will leave us with two unknowns. There is a series of points along the line OS that will give us that slope, so we wouldn't be able to pinpoint a specific S. In order to do that, we're going to have to work out first the equation of OS. So that should be straightforward to do now that we have the slope of OS and we have a point, so 0, 0. So when we do that, using our formula from page 18, y minus y1 is equal to m bracket x minus x1. We get y minus 0 is equal to 1/3 x minus 0. So we're left with 3y is equal to x, or if you prefer, x minus 3y equals 0. So that's our OS. Now, they did tell us one other thing about that coordinate S, and it intersects the line PQ at S. So S is that point of intersection. So it's the point of intersection of OS and PQ. So we're going to find now the equation of PQ. So for PQ, you have a few different options. So we're going to use the point 30, which is P, and its slope, which is 2. And when we work that out, get y minus 0 is equal to 2 bracket x minus 3. Y is equal to 2x minus 6. And again, if you prefer to rearrange it, that's fine. So this here is our equation 1, and this is our equation 2. And we're going to get the point of intersection by working with equation 1 and equation 2. So equation 1, x minus 3y equals 0. This is 2x minus y is equal to 6. So we're going to multiply the top line by minus 2 to get that to cancel. So we get minus 2x plus 6y equals 0. Gives us 2x plus y equals 6. These cancel. We have 7y equals 6. Sorry, apologies. I have correct sign there. It should be a minus y, and that leaves us with 5y equals 6. So y is equal to 6 over 5, or if you're putting in decimal, 1.2. So then to figure out what the x coordinate is, we can go back to equation 1 just because it's a little bit simpler. And we have x minus 3 times 6 over 5 is equal to 0. So x is equal to 18 over 5 or 3.6. So the coordinate here, 18 over 5, 6 over 5, that is the coordinate of S. So there's a lot to that question there. It wasn't just one little piece. There was quite a lot, and we see that with coordinate geometry of the line questions. Often you can have to do a series of little pieces. Now, using that formula of the tan of theta shouldn't have been too bad. Getting the equation of a line has come from junior cert. It's simultaneous equations, junior cert. So like none of the maths in that is quite difficult. It's just about bringing it all together and knowing that that was what you needed to do.